Oceans cover a huge part of our planet, more than 70%. That's almost 3/4 of our world. But not all of that water is liquid. Maybe you live in a place that gets cold enough to snow. Did you know that most of the fresh water on our planet is frozen? And in some places, the weather is so cold over a long period of time that the snow and ice never melt completely? Let's talk to someone at NASA who can tell us more about those really cold places and why NASA is interested in studying them.
So we're all familiar with the weather. One day it might be windy, another day it might be sunny, or maybe it's rainy. Those weather patterns over a long period of time make up what we call climate. Another way I like to explain it is climate is what you expect, but weather is what you get. So the climate all over the world is different in different places. Near the North Pole or the South Pole, it's cold year-round, and those are what are called the polar areas.
It's icy at the poles, of the North Pole as well as the South Pole of our Earth. This is where we have these white ice caps. A big difference between the Arctic in the north and the Antarctic in the south is that the Arctic, the North Pole, is ocean, which is surrounded by land, United States, Canada, Russia, whereas the South Pole is land surrounded by ocean.
But what's so special about these icy places anyway?
So in the polar regions, we have continents where snow falls, and it's so cold there it doesn't melt in the summer, and that snow falls and falls and accumulates and accumulates, and it builds up and it builds up and it builds up. And through time, over thousands of years, they make what we call an ice sheet. So ice sheets are ice that's on land.
So land ice, or ice sheets like glaciers and icebergs, form on land. But in parts of Earth's polar regions, ice covers our oceans.
Sea ice, or ice that's floating in the ocean, is different. Sea ice is formed when ocean water gets cold and gets down to 0 degrees C or 32 degrees Fahrenheit, and that seawater freezes. And instead of making an ice cube like you see in your freezer or in your glass of water, it makes what we call sea ice.
Just like an ice cube floats in a glass of water, sea ice floats on top of the ocean. But whether it is an ice sheet or sea ice, scientists have been paying attention to what is happening to the ice on Earth. It is melting faster than they expected. So just how do we watch something as big as Earth's polar regions? NASA uses a satellite.
ICESat-2 is a satellite that will be in orbit around the Earth, and it measures the height of whatever it's pointed at. So for sea ice, it will measure the thickness of the sea ice by measuring the height of the ice surface and the height of the water next to it and taking the difference.
And as you measure the distance from the satellite down to the surface of ice, we're able to tell how thick the ice is over time. And we'll pass back over that path. We know whether the ice has grown or it has melted.
In addition to the thickness of the sea ice, we can measure the elevation of the entire Earth. We measure the third dimension of our globe.
But what is so important about Earth's ice, and why do we care how fast it melts?
One of the easiest ways to think about it is we have a polar ice cap in the Arctic, which covers most of the Arctic Ocean. When that ice begins to melt, either due to warm temperatures below or above, the area of the ice gets smaller. And so the amount of sunlight that normally gets reflected from the ice is actually instead absorbed, and so the ocean temperatures themselves heat up. And that in turn raises temperatures in the Arctic, which then in turn also cause more melting of the ice. Both the ice and the oceans in the polar regions drive global climate.
Okay, so the oceans and the ice in them help control the temperatures on Earth. And with the help of ICESat-2, NASA will be able to watch the changes in ice thickness. And all that information can be used to help us take better care of our world.